Let's take a look at this equation and let's see how we can use factoring to solve it really quickly. I mean, this shouldn't be anything mysterious to us. If I added 24 to both sides, I would get that x squared plus 14x plus 24 is equal to 0, and I can factor this into x plus 2 times x plus 12 equals 0. And so I would know that x is either negative 2 or x is equal to negative 12. This is assuming that we're pretty good at factoring and that we are fairly comfortable with the zero product principle. Let's suppose instead of x squared plus 14x being equal to 24, negative 24, let's say that it was equal to 4. Well, you'll realize that when I move that over, I'd be looking for factors of negative 4 that would combine to give me a positive 14, and that's just not going to happen. I don't have factors of negative 4 that'll combine to be a positive 14. So that factoring in this case is completely out of the question. So what if we used a new technique called completing the square? So if I had a polynomial that said x squared plus 2x y plus y squared. Now, what I recognize here is that this is a perfect square trinomial. The first term is squared, the last term is squared. So the first term is x, the last term is y, and what I've got is I've got the first term squared here, the last term squared there, and the middle is if I just take these two and multiply them and then double it, then I have a perfect squared trinomial. This sign is positive, so that sign is positive, and then I have that squared. And so our goal to solve a quadratic by completing the square would be to manufacture this scenario here, to have a first term squared, to have a last term squared, and have this term here be twice the roots of that guy there and that guy there. So in order to do that, I need to add another number here. What number should I add? Well, if I want 14 to be twice the roots, then 14 is twice of a number. What number is that? If I divided 14 by 2, I get 7. Okay. So if my square root over here is x, then my square root over here is 7, because 7x plus 7x gives me the 14x. Great. This term is x squared, so this term then must be 7 squared, and 7 squared is 49, and since it's squared I have to add it. You always add perfect square numbers. And again, in order to maintain balance, if I add 49 over here, I have to add 49 on this side. So now on the right, we just have 49 plus 4 is 53. And on the right, what we've manufactured is this scenario here. We've put that together. So then I should be able just to have a binomial square in order to get this. Well, our square root over here is x, our square root over here is 7, this sign is positive, and that bears out, right? If I were to distribute that out, I would get x times x is x squared, x times 7 plus x times 7 is 14x, and 7 times 7 is 49. So that's good. That's what we did. And in order to do that, well, the reason that we've done that is so that we can take the square root of both sides. So you've done this before. And so when I take the square root of both sides, this square cancels with the square root, and I'm just left with x plus 7 on the left. On the right, I have the square root of 53, which I don't think is a rational number, so I'm going to have to leave it as the square root of 53, but it's plus or minus the square root of 53. And then to finish this equation, I need to get x by itself, so I'll subtract 7 from both sides. and these will cancel, and so x is equal to negative 7 plus or minus the square root of 53. So the roots of that would be something like, okay, here is my graph, 7 minus the square root of 53, which is just a number, right? We can pull up the good old trusty calculator here. We'll do 53 square root. That's a little more than 7, so if I take negative 7, let's try that again. We'll do that minus 7, that number minus 7, so it'll be negative 7 plus 53. It's just a little bit more, so we've got a point here at 0.2 something something something. And then if I subtracted that number, let's see, we'll do it this way. We'll say 7 negative minus 53 square root equals, that's negative 14. So there's my other root is over here at negative 14.28 something something something. And so my parabola will cross at those 2 points eventually, you know, meeting at some kind of vertex. I don't know where the vertex is, but it looks something like that. And these are my two roots, negative 7 plus and negative 7 minus.